Another type of non-Euclidean geometry is finite geometry, in which there's a finite set of points. So we can look at 4 points. We'll call them A, B, C, and D. These are the only 4 points in this geometry, that's why it's finite. And a line is made up of exactly those 2 points. We could draw a line by connecting the dots, but there's nothing in between them, so it's just those 2 points. So if we draw all of the lines, it's every possible way of connecting any 2 dots. Now, since there's nothing in between, AC is a line and BD is a line. The drawing can be misleading because it looks like they intersect here. But remember, there's nothing in between. They can't intersect because there's nothing there. There's no point where they can intersect. So AC and BD do not intersect. In this finite geometry, lines will only intersect if they have the same letter used in both of them. So AB and AD intersect at point A. AB and BC intersect at point B because they share point B. So we could look at a different finite geometry with a different number of points. So here we have a finite geometry with 7 points in it, and it takes 3 points to make a line. So here's our lines for this finite geometry. So let's determine if the following statements are true or false. 2 distinct lines intersect in exactly 1 point. So that means that they can only share 1 letter. So just looking at the lines that we have ABC, AGF, they only share A. AED only shares A with either of those 2. BGD shares B, shares G, and D, but only 1. CGE shares 1 point, 1 point, 1 point, and point G is shared, so it shares 1 point. CFD, C is shared, F, D, D, C is shared. And for EBF, B is shared, F is shared, they intersect at E. EBF would intersect here at B and only B. CGE would intersect at E and only point E. And finally CFD is only going to intersect at point F. So yes, they only intersect at 1 point because they only share 1 common letter between any pairing. Each point is on exactly 3 lines. A, and that's it. B, and B, and that's it. C, and C, that's it. Point D is shared in 1, 2, 3. Point E, 1, 2, 3 lines. Point F, it's in 1, 2, 3 lines, and last point G, 1, 2, 3 lines. So yes, that's true as well. Each point is on at least one line with every other point. So that means we're looking to see if A is on a line with every other letter at some point. So there's B and C, B and E, F and G. Yes. B is where we checked A. We only need to check the letters that come after it. B is with C, D, E and F, and G. Then check point C. It's with G and E, F and D, and that's all we had to check for C, because we don't have to check letters that come after it, because we're already checked them before with the other letters. Point D, we need to make sure that it's written with E, F, and G. There's E, D with G, and D with F. Yes, it's every other point. Point E, need to make sure that it's in lines with F and G. Here's E with G and E with F. Now we're going to find F and G in the same line. Here it is in AGF. So yes, every point is in a line with every other point. For every pair of points, there's exactly 2 lines containing neither point. So we have the pair AB. It cannot have A nor B. So that one's okay, that one's okay. Then we can check the pairing of AC. Both in there. A, C, C. There's 2, so that one's okay. Next we can check A with D. It has A, that has D, that has D. There are 2, that's good. Next let's check A with E. That has A, that has A, that has E, and that has E. There's 2, good. AF. Cross it out if it has either A or F. There's 2 that don't have it. That's what we're looking for. Take the AG pairing. And there's 2. So you still have to check BC, BD, BE, BF, and BG, and then CD, CE, CF, CG, DE, DF, DG, EF, and EG, and last you check FG. Make sure that none of those, just go through like we did with all of them that had A, Let's see if there are exactly two lines containing neither point. I'll leave that for you to try on your own. And this last question here, if any three lines are not concurrent, that is, they do not all share the same point, there's exactly one point that is not on any of the three lines. So let's take the line ABC for example, and they can't all intersect at the same point, so they can't be, for example, they can't be ABC, AGF, and AED, because they're concurrent, they all intersect at A, sorry. But we could do ABC, AG, F, and for example, we could then take CFD as our third line. So since they can't all share one point, they have to at least share a point somewhere. ABC and AGF intersect at one point. As long as the other one doesn't also intersect at A, they are not concurrent. But then if you just look at how many letters we would have to use, 3, 4, 5, 6 letters. So that means there is one letter that's not used. In this case, D is the letter that's not used. We could have not used D if we would have used E instead for the line EBF. If EBF was our other line, we would still only be using 6 letters total, which means there's a 7th letter that we did not use, and that would be point D. So as long as you kind of think about making this into a triangle where they all intersect but not at the same point, we introduce 3 letters with our first line, 2 new letters with our second line because it's going to intersect at one place, and then we are only introducing 1 new letter with our third line because it's going to form the triangle and intersect the other 2 lines at 1 point each. So we can do that to use 6 letters, which means there is a 7th letter that's not on any of the lines.